In this video, we're going to look at the proof of the quotient rule by the definition of derivative. So here we have h of x is f of x divided by g of x. Recall that the definition of derivative is a limit as h approaches 0 of f of x plus h minus f of x all over h. We're going to apply that definition to our quotient, f of x over g of x. So here we have the limit as h approaches 0 of f of x plus h divided by g of x plus h minus f of x over g of x, all divided by h. Okay, here we have a complex fraction, fractions within fractions. So in order to work with that, we need to simplify. The easiest way to do that is by multiplying by the common denominator over the common denominator. So I'm going to do that here. My common denominator is g of x plus h times g of x. In effect, I'm multiplying by 1, so I'm not changing anything. Let's go ahead and simplify a little bit. If I multiply the numerator by g of x plus h times g of x, I'm going to multiply each of these pieces by that LCD. Okay, in the first term, the g of x plus h is going to drop out, and I'll be left with f of x plus h times g of x. When I multiply that LCD by the second term, the g of x is going to drop out, and we'll be left with f of x times g of x plus h. Oops. The denominator will be the product of three factors, h, g of x plus h, and g of x. Okay. In the next slide, you're going to see it as 1 over h times f of x plus h times g of x minus f of x times g of x plus h all over g of x plus h times g of x. Recall from our last video about proving the product rule, we had something that looked like this, and we did a little trick by adding 0. Okay, so what we're going to do is we're going to take this fraction and we are going to add 0. But 0 is going to look like negative f of x times g of x plus f of x times g of x. So we're going to have the limit as h approaches 0 of 1 over h f of x plus h times g of x minus f of x times g of x plus f of x times g of x minus f of x times g of x plus h all over g of x plus h times g of x. Okay, in our next slide, we're going to break up this huge fraction into two parts. Okay, and recall that if we had 2 plus 7 over 5, we could break that up into 2 over 5 plus 7 over 5. So we're going to use that idea and break up this big fraction. Okay, so here you see we've added 0. And we're going to break up this fraction into 2. So I will have f of x plus h times g of x minus f of x times g of x over the denominator g of x plus h times g of x. That's the first fraction. The second fraction will be f of x times g of x minus f of x times g of x plus h all over the denominator of g of x plus h times g of x. Okay, we're going to do a little work on these fractions. In the first fraction, we can eliminate a factor of g of x. So we'll have 1 over h f of x plus h minus f of x all over g of x plus h. Oh, I need to fix something here. My parenthesis is in the wrong spot. That 1 over h is being multiplied by both of these fractions. Okay. All right, let me go ahead and distribute that 1 over h to the next piece as well. And in the second fraction, f of x times g of x minus f of x times g of x plus h over the denominator, let's factor out a negative f of x. So negative f of x times g of x plus h. I'm going to reorder these since this guy will become negative and this guy will become positive over g of x plus h times g of x. Okay, I said I was going to distribute that 1 over h, so the first fraction has a 1 over h, and the second fraction has a 1 over h. Okay, we're going to rearrange this a little bit more so that we can see derivatives happening. So I actually went a step further in that previous slide, and I eliminated, and I did pull out the negative. That should be, okay, that is negative. Okay, just checking here. So let's move to the next slide and see what I've got. Okay. So let me come back here, and I just want to copy this so you can see what's happened. So remember, from this, we went and did a little reducing and factoring, and now we're just going to reorder or rearrange how these pieces look. So just double check that we have everything. We are going to swap the locations of h and g of x plus h. So here we have 1 over g of x plus h. Now we have f of x plus h minus f of x all over h. Okay, looking at the second fraction. Okay, we are going to again swap h and g of x plus h times g of x. So here we have f of x over g of x plus h times g of x. And here we have g of x plus h minus g of x over h. All right, also using the limit properties, right? We had the limit of products, the limits of the sums. All right, we're breaking that up. The limit of a product is the product of the limits. So we're going to take the limit of 1 over g of x plus h as h approaches 0. That's just going to become 1 over g of x because h can go to 0 without any problems. The second piece, the limit of f of x plus h minus f of x over h, that is f prime of x by the definition of derivative. All right, we have minus the limit of f of x over g of x plus h times g of x. We can let h go to 0. That's not a problem. We'll be left with f of x over g of x times g of x, or g of x squared. The next limit of g of x plus h minus g of x over h, that is g prime of x. All right, so we have taken the limits. We have fractional pieces, a difference of fractions. We are going to get a common denominator fraction. So it looks like my denominator should be g of x squared. So let's add a g of x factor to this first fraction. We'll need to add that to both the numerator and the denominator. And let's simplify just to make it look a little bit better. So we have g of x times f prime of x minus f of x times g prime of x all over our denominator, which is g of x squared. Okay, and this is the derivative of h prime of x, or h of x, sorry, it's a derivative of h of x, which is h prime of x. All right, and there is your proof by the definition of derivative of the quotient rule. Okay, if you do call your function h of x is f of x over g of x, sometimes they refer to the high piece and the low piece of the fraction. So h prime of x is low d high minus high d low over low low. So if the little jingle helps you remember d low just means derivative of low, d high means derivative of high. All right, you could also do that with up and down. Up being the numerator, down being the denominator. You could say down d up minus up d down over down down. In general, just remember you need to start with your denominator. So it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared. Order matters in this case because we are talking about the quotient, and in there we are talking about subtraction. Okay? All right, good luck using the quotient rule.